All right, let's look at this is our study guide from call it test 5. We only took one test so far, but it's mostly from week 5, springtime, from algebra 2. One says 2x minus 4 over 2x plus 10. You have to see what they have in common. On the top, they have 2 in common. 2 times x gives you 2x, and 2 times negative 2 gives you negative 4. They got 2 in common on the bottom as well. 2 times x and 2 times positive 5. Yeah, this one looks a whole lot like the bell works, not a coincidence. Cancel out 2 over 2. X minus 2 over x plus 5. The same thing with number 10. 10x squared's on top. Can't do anything with that one. But what do they have in common on the bottom? They have x squared. Pull that one out. It gives you 1 minus 2x. And then what they have in common on both the top and the bottom is x squared. Leaves you with 10 over 1 minus 2x. Number 3, you got to factor out x squared plus 4x minus 5. Two binomials, x times x. The only factors of 5 are 5 and 1. The negative in front of C tells you they're going to be opposite signs. This one tells you the larger one's positive. So plus 5 minus 1 over 1 minus x. Nothing else we can do with this one. Yeah, that was one that's why, going back to what I was telling you about this being the easiest stuff you do and the hardest stuff, because you don't know what you're supposed to do with it, when you're supposed to be finished with it, is a better way to say that, I should say, when you're supposed to be finished. Number 4 says x squared minus 2x minus 24 over another trinomial. Let's do the top one first. So we have x times x, and then you have to find your factors of 24 that are going to get you to 2. 6 and 4 is the only ones that are going to get you to 2. So you have to use 6 and 4. This one tells you that they're going to be opposite signs. This one tells you the bigger one's minus or negative, so that one's going to be negative. This one's opposite's positive. Do the same thing at the bottom, x times x. 36, your factors of 36 that are going to get you to 5 or 9 and 4. 9 and 4. Again, this right here tells you they're going to be opposite. This one tells you the bigger one's negative. So that one's negative. This one's positive. You can clearly see what they have in common now. X plus 4 on top and bottom. So x minus 6 over x minus 9. Number 5, two trinomials again. We have x times x. What factors of 8 are going to get you to 2? You have 8 and 1. You have 4 and 2 are the ones that you're going to have to use. 4 and 2. Again, this one, the opposite. This one, the larger one's negative. So right there, factor the bottom out, x times x. What factors of 6 are going to get you to 1? The factors of 6 that are going to get you to 1 are 3 and 2. It's 1 because there's b values 1 here. Opposite signs, larger one's negative. Again, you can see what they have in common, plus 2. So x minus 4 over x minus 3. Number 6, you're multiplying. You could actually cancel out 4 and 2 right now and make it 2 over 1. But if you multiply them out to where we can see 4 times 3 gives you 12, and 5 times 2 gives you 10, a to the first power times a squared means 1 plus 2. You get a to the third power. Then cancel out what they have in common. They have a 2 in common. 2 times 6 gives you 12, and 2 times 5 gives you 10. So you have 6 over 5, a to the third is all we can do with that. Number 7 looks familiar too from the bell word. When you multiply them across, you get negative 4q times q minus 5. I just reordered the top over negative 4 times q minus 2. It's easier to see what they have in common at that point. They have negative 4 in common, so cancel that out. And you're left with q times q minus 5 over q minus 2. Number 8, you have the difference of a perfect square on the top, x squared minus 16. You can take the square root of x squared and get x. You can take the square root of 16 and get 4. But since it says negative in front of that c value, the b value is missing in the middle. But since it says negative in front of the c value, that means they have to be opposite signs. So you have two binomials, just like we do when we factor out a trinomial, x times x. You use the numbers 4 and 4, but one has to be positive and one's got to be negative. over we have 6x times 7x over x plus 4. Nothing we can do with those, but we can see what we cancel out. X plus 4 over x plus 4. So we still have 7x on the top. We still have x minus 4. Notice I just reordered it. I just to put the monomial first instead of the binomial. But if you put the x minus 4 first, it's the same thing. Over 6x. And then there's one more thing they have in common. They have x in common, so we can cancel that out. So 7 times x minus 4 over 6. This is going to be over 1 if you need to look at it that way. Everything when you're multiplying, dealing fractions, just put them over 1. And so what does, we factor out each of these. The top, we can't do anything to it just yet. K plus 3. We can take a 2 out of the bottom. 2 times 2k is 4k. 2 times negative 1 is negative 2. And then on the top of the second one, it says 12k squared. You could take a 3 out of that. So 3 times 4k squared and 3 times negative 1 over 1. Now, just like we had a perfect square in number 8 on the top, this is one of the perfect squares that's not as noticeable for some people. Had it said k squared minus 1, it would be easy because you could take the square root of 1 and the square root of k. But this one gives you the number 4 that you have to take the square root of first. So it is a perfect square just like the other one, but it looks like this. The 3's still there, but then it's the square root of 4, which is 2k plus 1 and 2k minus 1. So it acts just like number 8 when we separated x squared minus 16, but the 4 needs to be factored out as well, 2 times 2. So that's over 1. We'll bring the rest of it down where we can see everything, k plus 3 over 2 times 2k minus 1, and we can see what we have to cancel out at that point. They both have 2k minus 1 in common. So now we have, just to put the monomial first, 3 times k plus 3 times 2k plus 1 over, all we have left on the bottom is 2. And again, it gets back to what I told you about not knowing exactly when you finish. Am I supposed to FOIL that out? No, that's what you have to do right there. There's nothing else you can do to cancel that out. Number 10, we're still multiplying. We have the difference of perfect squares right there. Y plus 5, y minus 5 over negative 2y times 3y over y plus 5. You can see what you cancel out right there, y plus 5. So just to put the monomial first, 3y times y minus 5 over negative 2y. Not quite finished. There's one more thing we could cancel out. We can cancel out y. Cancel that out, and it leaves you with 3 times y minus 5 over negative 2. The number 11, it says negative 6 plus the square root of 3 squared. That means you have to square the entire binomial. Negative 6 plus the square root of 3 times negative 6 plus the square root of 3. You have two binomials that you're squaring them. That means you need a FOIL. Negative times negative, positive 36. Outers, negative 6 times that is minus 6 square root of 3. Inners, negative 6 times the square root of 3. Again, negative 6 square root of 3. And last, positive times positive is going to be positive square root of 9. And we know the square root of 9, or based on the shortcut, multiplying the same radical by itself takes it out of the radical symbol, plus 3. Combine your like terms, 36 and plus 3 is positive 39. Your other like terms at the same time are negative 6 square root of 3, negative 6 square root of 3, which is minus 12 times the square root of 3. Number 12, we shift to dividing. Dividing acts just like multiplication, except you have to flip the fraction of the second one. If you need to look at it, you look at it as over 1. Again, we treat it the same way, though. It's a perfect square on top, so x plus 2 times x minus 2. This is that'll be one of your most common mistakes right there, not factoring that part right there out. It's a real simple concept. Over x minus 8. It says division again, so you change division to multiplication and you use the reciprocal, 1 over x minus 2. Cancel out what they have in common, x minus 2. So you have 1 times x plus 2 on top. You don't have to write the 1 over x minus 8. You got a trinomial to factor out. At the top, x squared means x times x. You need to use the factors of 20, which are 5 and 4. Those are the only ones that get you to 9. This tells you that they got to be the same sign. This tells you they both positive. So plus 5 plus 4. The difference of perfect squares, x plus 5 times x minus 5. That says, again, division. That means change it to multiplication and use the reciprocal. X minus 4 goes on top and x plus 4 on bottom. Cancel out a bunch of stuff right here. We can cancel out x plus 5 and we can cancel out x plus 4. We left with x minus 4 over x minus 5. Again, we have a division problem. We have s squared minus 5s. Take out what they have in common. They both have an s in common, and they'll use s's and 5s together in textbooks and on standardized tests plenty. That's why we're doing this problem. Pull that s out, and you multiply it times s to get s squared, and you multiply it times negative 5 to get negative 5s over. Factor out the next one, s times s. Your factors of 15, that gets you to 8, or 5 and 3. This tells you that they're going to be the same sign. This tells you they're both negative. So minus 5, minus 3. We can already see one that we can cancel out. Again, it says division. So that means multiply by the reciprocal. S minus 3 is on top. S plus 2 is on bottom. Cancel out. S minus 5. Cancel out S minus 3. S is still on top. S plus 2 is on bottom. And you can't cancel out. If you look at that and you say, well, can I cancel out s over s? No. Because of the fact that it's adding to 2. It's a binomial. You can't cancel it out. Then it says solve by graphing. I don't expect you to solve it by graphing, but if you did, it would look like this. You would move negative 2x over and you get negative y equals positive 2x minus 3. And you divide by negative 1 on both sides and you get y equals negative 2x plus 3. So when you graph that equation, it looks like plus 3, 1, 2, 3. You go down 2 and over 1 to that point, and your equation's right there. The other equation, when you move it over, you move x over, and you get negative y equals negative x plus 6. When you divide by negative 1 on both sides, you get y equals negative divided by negative is a positive 1x minus 6. Start at negative 6. Slope tells you to go up 1 and over 1 right there, and your equation will look like that. So if you were solving this, you would be interested in that point right there. It's xy value. An easier way to do this, and most of y'all are more comfortable doing this, is to use the substitution method. We already did this work right here and got a value for y. Plug that value into the other equation. The other equation says, and it doesn't matter which version you use, I'll use this version right here. Plug that x minus 6 in place of y. So negative and then x minus 6 equals 2x minus 3. Distribute that negative 1, you get negative x plus 6 equals 2x minus 3. Move negative x over by adding it to both sides, and you get 3x. Move negative 3 over by adding it to both sides, and you get 9 is 3x. Divide by 3 to get x by itself. You got a value for x now. It's 3. So your value for x is 3. Plug that value in, substitute it back into the other equation right there. So y equals 3 minus 6. Y equals negative 3. So the point that solves this one is x comma y, and its values are 3, negative 3, which is the ordered pair right there. 3, negative 3. This one says use elimination to solve it. Elimination just means you want to combine them and get rid of one of them. In order to use elimination right here, you have to move one or more equations. If we combine 4 and 3, we're going to need to make their least common multiple, which is 12. It means we need to multiply this times 3 is 12x. This times 3 is 15y. And this times 3 is equal to 30. We have to make the bottom one negative to be the opposite. We got to multiply it by negative 4. Times that is negative 12x. Times that is positive 12y. And times that is positive 24. Now you can combine them and eliminate 12x and negative 12x. There'll be no more x's there. 15y and 12y is 27y. And 30 and 24 is going to be 54. When you divide by 27 on both sides, as ugly as that is, it is a factor of 54, and it's 2. So you got y equals 2. Plug that into any of the other equations. I'll grab the first one, 4x plus 5y equals 10. Plug in 2 in place of y, 4x plus 5 times 2 equals 10. 4 times x plus 10 equals 10. Subtract 10 on both sides, and you get 4x equals 0. So x equals 0. X comma y is 0, 2.